Hi, I'm Melissa Hartwig, and today I'm going to talk to you about parameterizing piecewise paths. Now, to do this, we're going to have to come up with vectored valued functions. And since our path has three pieces, R1, R2, and R3, we're going to have to come up with three vector valued functions and put them all together into one piecewise. So, we're going to start with our R1. It is the easiest one to do because it is the only one going from left to right, and left to right means we don't have to make any changes in our parameters. So we can see we have y equals x squared, so we know that as x increases, y increases by a value of x squared. So our first component will be a simple t of I, or t in the I direction, plus t squared j, and that covers that curve. From, as we can see, we want to go from 0 to 2, so it would be 0 less than or equal to t less than or equal to 2. And that's it. That's all we have to do for the first piece. Nice and simple. Now the second part of our path, our R2 up here, which is along the line y equals 4, is a little bit harder because it is going from right to left, so we will have to make some changes as we go. We're going to start out with saying we have R2t. Now, our I component is clearly negative because our path is heading from 2 to 0 in that direction. So we're going to say negative t of I. Now, our y component is always 4. So our j component will be a simple 4, 4j. Now, the way that we have this written here, this is going to take us from negative 2 to 0. But that doesn't follow along our path here that ends at 2. So we're going to have to make a quick change in order to make it fall into line the way that we need it to. So what we're going to do is we're going to add a little subscript 1 to each of the t's in our R2. And now we know that we want our R2 to start at t2, t equals 2. So in order to get that there, we are going to have to add 4 throughout this part of our equation in order to get this to go from 2, it's going to go all the way up to 4. Oh, no, sorry. It should be t1 plus 4 to 4. Now we need to solve for this centered part here, because obviously we don't want it to be t of 1 plus 4. So what we're going to do is we are going to let t equal t of 1 plus 4. Now, we have a negative t of 1 here, and we want to get our t in the middle. So we're just going to switch these two. So we'll have a minus t1 equals 4 minus t. And so anywhere where we have a negative t1, we're going to insert this. So that will go right here. So that makes our R2 of t equal to 4 minus t in the I direction. We keep that 4 in the j direction. And now this is going to go from 2 to t to 4. And we change this to simple less than rather than a less than and equal to because we don't want 2 points at t equals 2. Now for the third part of our path, our R3, we're going to have to do something very similar because we're going from top to bottom. So we're going to have to make this same kind of a change. So we're going to start with R3, which has no x component because we're simply on the y-axis. So our x component would be 0, so we'll just leave that out. We do have a minus t j. Now, if we set it up this way, our minus t is going to go from negative 4 to 0, so that we can get from 4 to 0 here. But again, this negative 4 doesn't line up with this 4, which is what we want it to do. So we're going to put a little subscript 2 on these t's. We're going to do a really similar process. So we know we need to get to 4, so we're going to have to add 8 to everything here. So that we get from 4 to t2 plus 8 all the way to 8. And we're going to come and we're going to let t equal t2 plus 8. Do the swap again. So we have a minus t2 equals 8 minus t. And so wherever we have a t2, we're going to negative t2, we're going to substitute. And we have that right here. So our new R3 of t is going to equal 8 minus t j from 4 to So now we have our three separate pieces of our function. And so what we're going to do is we're going to put them all together in a piecewise. So we'll set it up like this. And we start with our R1. So ti plus t squared j from 0 to 2. And then 4 minus ti plus 4j from 2 to 4. And then finally, 8 minus tj going from 4 all the way to 8. And there you have it. We have parameterized a piecewise path using three separate vector-valued functions.